We would like to be able to look at the position versus time graph of any moving object and draw the corresponding graph of its instantaneous velocity versus time. We'll start by looking at little segments of position versus time graphs. We've got 7 of them here. Every position versus time graph can kind of be broken down into connections of these 7 different pieces. So if we know what the velocity graph for each of these 7 pieces looks like, and then we can construct the velocity versus time graph for any position versus time graph. Starting here, here we've got an object that is clearly not moving at all. Its position versus time is horizontal. It's at the same position at every moment. If we draw in our tangent lines at these 2 endpoints, well, the tangent line is just the horizontal line. It's the same as the line itself. The slope of that tangent line is 0. So a graph like this corresponds to an object not moving. That is, it has a velocity of 0. This one, we have an object moving in the positive x direction. We can draw in our tangent lines at the endpoints to figure out what the velocity, the instantaneous velocity, looks like. Here we've got a positive slope here, that's the same as the slope of this line segment itself. The slope is the same at the 2 endpoints. The velocity is the same the whole time. This straight line indicates that we have a constant velocity. That's a key idea. A straight line on your position versus time graph means constant velocity. Because it has a positive slope, we know we have a constant positive velocity. So our velocity here is some positive value greater than 0, and it stays the same the whole time. It ends up at the same positive velocity as it was at the beginning, moving in the positive x direction. Here we've got a straight line segment again on position versus time, so we know, aha, this is also a constant velocity. Because if we draw our tangent line, the tangent line is the same at any point on here, and the slope of that tangent line is the same as the slope of the line segment itself. So a constant velocity, and we see that this one has a negative slope. So on our velocity versus time curve, we have a negative velocity, so we're below 0 down here, and it stays the same the whole time, a constant negative velocity. Now these curved segments. This one, we've got a curve going down and to the right, so it looks like the object starts moving in the negative x direction, moving pretty quickly at first. We draw our tangent line, and there's a line with a sharp negative slope. But then by the end, tangent line, it's still a negative slope, but not so steep. So large negative velocity at the beginning. So at the beginning, negative velocity, we're down here, a large negative velocity. And still negative, but smaller at the end. It's not moving as quickly towards the end here. So a small negative velocity because of our small negative slope here. Small negative velocity. So negative, we're below 0, but kind of close to 0, a small negative value. Once we plot in those endpoints, we can kind of connect them, make our best guess is probably a pretty straight line from there to there. So we see that our velocity starts out very negative, moving quickly at first, but then slowing down, approaching 0. Still moving in the negative x direction the whole time, but at a decreasing rate. This curve, let's draw in our tangents at the endpoints. Okay, positive velocity here, but a greater positive velocity here. This object is moving in the positive x direction, slowly at first, but then picking up speed. It's accelerating. Its velocity is becoming more and more positive. That slope we see is becoming more steep with time. So we've got a positive velocity in the beginning, but kind of small positive velocity. So we're above 0, small positive velocity. And by the end, we have a large positive velocity, moving very fast. So positive velocity. Let's just connect those 2 lines, or those 2 dots. And so we're showing here on our velocity graph that we start out, we're moving in the positive x direction the whole time, because our velocity is always positive. But it starts out moving slow, ends up moving very fast. This segment, draw in our tangent lines. Okay, at the beginning here, we're moving in the positive x direction. And we're still moving in the positive x direction at the end, but we've slowed down. Here, steep slope, we're moving fast at the beginning, and then we've slowed down by the end. So positive the whole time, but faster at first. So a fast positive velocity goes there on our velocity graph. Here we're still positive, but slower. We're kind of approaching zero. We're slowing down. So positive, but small by the end. We can just connect those two roughly with a line. Last one, draw in our tangents. Okay, both these tangent lines have a negative slope. This one's kind of shallow. This one's very steep. Small negative velocity right there. Small negative. We're below zero, but close to the zero axis, meaning small. And here, large negative velocity, meaning very negative, below zero and far from the zero axis. And we can connect those two. And there we have it. Any other position versus time graph we can build up out of these 7 segments. And now we know what the corresponding velocity segment looks like for each of those position segments. One note before we move on. The position of x equals 0 on your position versus time graph does not matter. Here's an example. 3 position versus time graphs. The shape of the curve is the same each time, but notice here x equals 0 is right there. We're in positive territory the whole time. This time though, x equals 0 is right there. We start out at positive x values and move to negative x values. This time x equals 0 is up here. We're in negative x territory the whole time. Same shape of the curve, but we've moved the x equals 0 axis. Does this affect the velocity curve? Answer is no. Because look at the slopes of our tangent lines at the endpoints each time. To figure out our velocity curve, we only need to know the slopes of the tangent lines at the endpoints. And that's the same each time. Large negative, small negative. Large negative value, small negative value. Large negative value, we're moving quickly in the negative direction. Small negative value, moving slowly in the negative direction. Large negative value, moving quickly in the negative direction. Small negative value, moving slowly in the negative direction. The 3 velocity curves are the same. So it doesn't matter where the x equals 0 axis is. Your velocity graph doesn't have any information about where you are. It only tells you how you are moving. Okay. Let's put some of those 7 segments together, 2 at a time, to get some pretty commonly appearing sections of a position versus time graph. All right, on each of these 8 examples, we've put together 2 of the segments from the previous page. All right, let's look at each of these points, draw in our tangent lines. Okay, we've got a large negative velocity, then 0 velocity right here. Our tangent is horizontal, meaning for an instant there we're not moving. So it starts out with large negative value. We're moving quickly in the negative direction. Then 0 for a moment, our velocity is 0. And then at the end, we're moving back in the positive x direction. Large positive velocity right there. So we can connect those 3. So our object moved in the negative x direction, came to a halt for a moment, and then moved back in the positive x direction. Negative velocity at first, then 0, then a positive velocity. All right, we've got this upside down version of the previous curve. So here, large positive velocity at first, then turning point, horizontal tangent line, meaning a velocity of 0, and then by the end, we're moving quickly in the negative x direction. Large negative slope. Connect those 3 lines. Next one. Start out looking pretty horizontal right there, horizontal at the other end, and in the middle, a positive slope. So at the beginning, we started from rest, horizontal tangent, meaning 0 velocity. At the end, we came to rest, horizontal tangent, 0 velocity. But in the middle, we were moving in the positive x direction for a while right there. Positive slope. So we had a positive velocity somewhere in the middle. So this velocity graph looks something like that. Started at rest, then moved in the positive direction, then came to rest again. Here we start from rest, but we're moving in the negative direction and coming to rest again. So rest at the beginning, moving in the negative direction, negative slope, and rest again. So rest at the beginning, then we're moving in the negative direction, so we have a negative velocity, and then rest at the end, zero velocity. All right, down here, we start out moving in the positive direction. Then we've got a horizontal tangent right there. We came to rest for a moment in the middle, and then kept moving in the positive x direction. Moving quickly, came to rest, moving quickly again, always in the positive direction. So moving with a positive velocity at first, then we came to rest right there, then we're moving in the positive direction again. This one, starting out moving in the negative direction, came to rest for a moment, negative direction again. So start with negative velocity, come to rest in the middle for a moment, and then negative velocity at the end. All right, these last two are meant to be a little more subtle. I want you to compare this graph to this graph. Here we moved positive and came to rest, and then moved positive again. Here we're moving in the positive direction, but we don't quite come to rest. It looks like you're still moving a bit in the positive x direction right there, and then speeding up some more by the end. So we start out with a large positive velocity. We're moving quickly at first, then slowing down some, but not reaching zero. Still moving positive, but not reaching zero, and then speeding up again. End up with that large positive velocity. So the difference between this graph and this graph is that we don't quite hit zero in the middle right here. We're still moving. Didn't quite come to rest here the way we came to rest here. All right, over on this one, I want you to compare this graph to this graph up here. And this one, we started from rest, moved negative, and came to rest again. This time, we're not starting from rest. We're moving right from the get-go, moving in the negative x direction, then moving more quickly in the negative x direction. We sped up and then slowed down, but are still moving in the negative x direction by the end. So we start out moving in the negative x direction slowly, then we're moving negatively in the negative x direction quickly, then moving in the negative x direction slowly again. Connect those dots. All right, so we can compare these two velocity curves. This one shows that we started and ended at rest. This one says we started and ended moving slowly, but not quite at rest. All right, here's some exercises for you. We have 6 position versus time graphs on the left. I've got 6 velocity versus time graphs on the right. What I want you to do is match them up. These are labeled A, B, C, D, E, F. So for each position versus time graph, match it to one of these velocity versus time graphs. Some of these will be used more than once, some may not be used at all. Pause the video for a moment and match them up. Got the answer? Oh, I lost my answers. I have to figure it out myself. Okay, number 1 here, that is a constant velocity the whole time, constant positive velocity. That's A. Let's see, jump down to number 3, that looks familiar. That is B, -0, positive, -0, positive. Number 5 over here, that's also A. Now we changed the position of the x equals 0 axis here, but didn't change the shape of the graph. It's constant positive velocity the whole time. So that's that guy. Let's see, 4 is F, and then 2 and 6 are the slightly more tricky ones. Here we have a constant negative velocity at first, and then it slows down towards 0. So constant negative approaches 0. That's E. And here we are, here's the clue, we're at rest at the end here. Start moving negatively, but end up at rest. So we need a negative velocity at first, here we go, and end up at rest at the end. That's D.